Okay, so this is the second half of note sheet number 48, and this is proving quadrilaterals in the coordinate plane. And so, in this situation, we're actually going to use what we know about parallelograms to work backwards and find the missing vertex. Then we're going to go over those 4 homework problems that you had from the last video, and then you're going to go ahead and practice a combination of different parallelograms on graph paper. Okay, so first of all, let's get started. And whenever I think of geometry, I always think of drawing a picture. So I'm going to go ahead and I'm going to estimate where I think this parallelogram is going to fall on the coordinate grid. So 2, 3 is like somewhere over here. I'll call this point A. 8, 1 is going to be over here. 11, 5 is somewhere over here. And then point D is at, I'm going to assume it's somewhere right here. But we don't know this point yet. So I'm going to go ahead and draw this parallelogram. It's not perfect, but it's close. And what I'm going to do is I'm going to do something similar to what we did with the midpoint. I'm going to use the coordinates that I know to determine the ones that I'm trying to find out. So I know that from A to B is the same distance as from D to C. And I know that because of the properties of a parallelogram. And so if I can figure out what I do to A to get to B, I can do the same thing to figure out what I need to do to C to get to D. Or you could do the same thing going in this direction. If I figure out here to here, I can do the same thing to go here to here. So let's do this one. Let's say B is at 8, 1. And C is at 11, 5. Okay? And what I notice is that to get from 8 to 11, I'm just going up 3, not 2 to 3. And to get from 1 to 5, I'm going up 4. So now I'm going to come over here, I'm going to do the same thing to coordinate A. So coordinate A is currently at 2, 3. So I'm going to go up 3, and that's going to be 2 plus 3 is 5. And I'm going to go up 4, and 3 plus 4 is 7. So my coordinate for coordinate D is at 5, 7. So why don't you go ahead and try the next one and see if you can figure this one out. All right, so you pause the video and now you're coming back to check to make sure that you were able to find the missing coordinate S. So the first thing I'm going to do is I'm going to estimate how this looks on a coordinate plane. So negative 2, 4 is like here. 1, negative 2 is like here. We've got 3, 3 here. And so I'm going to assume that S is somewhere over here. Something like that. Okay? Not the best drawing in the world, but it is what it is. That's coordinate P. And so this is S, this is what we're trying to figure out. So what I'm going to do is I'm going to figure out to go from R to Q. So R is currently at 3, 3. And Q is currently at 1, negative 2. So what I notice is I'm going to subtract 2, because 3 minus 2 is 1. And over here, 3 minus 5 will give me negative 2. And so I'm going to do the same thing over here. Coordinate P is at negative 2, 4. And so I'm going to take away 2. And that's going to put me at negative 4. Over here, I'm going to take away 5. And 4 minus 5 is negative 1. So my coordinate S is at negative 4, negative 1. Okay. Let's try one more problem. This is just a review of finding all the missing angles in the rhombus below. So what do we know about a rhombus? We know all the sides are equal. And we know that the diagonals bisect each other. So if I know that this angle is 43, I know that this angle is also 43. Okay. I know the angles in the middle are 90. And so if I wanted to find this angle here, I would just do 90 plus 43. And 180 minus 133 is 47. So I've got a 47, 43, 90. So I know this one's 90. So I know this one's also 47. I know this one's 90. I know the diagonals bisect each other. So I know this is also 43, and this is also 47. This is also 43, and this is also 47. And so I'm good to go. Here was your homework from last night. If you need to take a moment to look at it. You can pause the video. You didn't have to do this one. Let's go ahead and look at the last one. Looks to me like it's a trapezoid. Okay, so now let me give you directions for what you're going to do today. You're going to get a couple of grids that look like this. Each one of these boxes presents a problem. You're also going to get graph paper that looks like this. Okay, and so you're going to use the graph paper to go ahead and draw the images and then answer them. So I'll do the first two with you. So the first one says, find the missing vertex of a parallelogram and determine its perimeter. And so this is parallelogram ABCD that is not multiple choice answers. So the first thing I'm going to do is draw my X and Y axis the best I can. And then I'm going to go to 0, 0. This is B. And -2, -4. This is C. And -6, 2. And this is point D. And so I'm going to assume point A is probably up here somewhere. Like somewhere up here. But I don't know exactly where it is. That's what I'm trying to figure out. All right, so the first thing I'm going to do is figure out, what do I do? I'm going to start down here. What do I do to go from here to here so I can go from here to here? Because I'm going to look from -2 to -6, I've subtracted 4. And to go from -4 to +2, I've added 6. So I'm going to do the same thing on this side. I'm going to subtract 4, which is -4. And then I'm going to add 6, which is 6. And let me see, if I estimated, I got, let's see. I was pretty close. I was just a little bit off. So this is actually where point A is. So my estimate is for you. Okay, so that's number 1. Check. We'll move on to number 2. You might want to go ahead and draw. I think they're already drawn for you. The next problem I'm going to do is rectangle ABCD. Go ahead and draw my coordinate grid the best I can. And I'm going to go to 0, 1. Here, label it A. 2, -3. That's B. C is at -4. -4, -6. And D is at -6. -2. And so this is my rectangle. So because I know it's a rectangle, I want to prove it's a rectangle. And so what I'm going to do is I'm going to go to my cheat sheet, which is on your notes from yesterday, the one that says use cheat sheet. I'm going to look at rectangle, and it tells me the first thing I need to do is prove that the diagonals are congruent but not perpendicular. So I'm going to look at this here, and if I'm proving congruent, I'm thinking a squared plus b squared equals c squared. So I'm going to go up and open. So I'm going to, let's see, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So this is 7 squared plus 4 squared. And I want to see if that is congruent to this direction. So for here, this is at 2, -3. And I can already see that these are not going to be congruent, but we'll see. So we've got 1 squared plus 8 squared. All right, let's see. So 7 squared is 49. This is 16. So 49 plus 16. That's 9, 10, 11, 12, 13, 14, 15. 4, 5, 65. It's very close. And over here we've got, this is 1 plus 64. And so 1 plus 64 is also 65. So this would be the square root of 65. Actually, these are congruent. For a second there, I thought they weren't going to be, but they sure are. The square root of 65 and the square root of 65. So check. They are congruent. And I can already tell they're not perpendicular. And the reason I know that is because the slopes are completely different. The slope on this one is 7/4, and the slope on the other one is -1/8. So I can tell they're not perpendicular, so therefore this is a rectangle. That's all we have to do. Now you're going to move on to the third problem. And go ahead and work these using your cheat sheet. Remember, it says prove that the quadrilateral is a rhombus. So the first thing I did, step 1 is draw. Step 2 is cheat sheet. And step 3 is prove it. And remember, the math you're going to be doing is slope, a squared plus b squared equals c squared, midpoint formula, and perpendicular lines are opposite and reciprocal. Good luck, guys. Please bring questions on Monday. I'll be back Monday. All right. Have a good one. Good luck.